In section 311, we are going to talk about collision. So let's say we have two particles which are moving on the same line, like this one with the mass of m1 and this one with the mass of m2. Let's say velocity of this one is v1 and velocity of this one is v2. And let's say v1 is bigger than v2. Because the velocity of this one is bigger than the other one, finally it's gonna hit this one, right? So after a few moments, these two are gonna collide, and for a moment, both of them are gonna move with the same velocity, right? So let's say that velocity is v naught. And depends on the material property of these two, they're gonna separate with different velocities. And velocity of the first mass is gonna be something else, which I'm gonna call it v1 prime. So v1 prime is the velocity of m1 after impact. And velocity of m2 after impact, I'm gonna call it v2 prime. So prime means after impact. And the question here is, if I know v1 and v2, what's going to be v1 prime and v2 prime, velocity of these two after impact? So we have two unknowns here, v1 prime and v2 prime. So I need two equations to find them, right? So if you look at this system, when these two are colliding with each other, there's going to be some impact force between these two. If you consider both of these masses together as one system, then that impact forces, those impact forces are going to be internal forces. So if you look at both of them together, the impact forces is going to be internal force, and we have no other forces from outside. So sum of the forces in this direction, let's call it x, is going to be equal to 0 for this system. So for these two masses together, sum of the forces is equal to 0 during the impact. And because there is no external force during the impact, we are going to have conservation of linear momentum. So because we have conservation of linear momentum, the linear momentum between 1 and 2 before and after impact is going to be the same. So G2 is equal to G1. And G2, the linear momentum after impact is each mass times the velocity of it. So m1 v1 prime plus m2 v2 prime. And the linear momentum before impact is each mass times the velocity of it. Then add them together. So this is going to be my first equation. I have two unknowns, and this is the first equation. I need one more equation. What is that equation? Do we have conservation of energy? Of course we don't. In general, we don't have conservation of energy whenever we have impact, because we are going to lose some energy. Unless both of the particles are extremely flexible or ideally flexible. If they are ideally flexible and act like a spring, we are going to have conservation of energy in that case. But in general, we don't have conservation of energy. The second equation actually depends to the material property of these two particles. For example, for this problem, if we have two pieces of, let's say, aluminum, then at the end we are going to have some velocities, right? But if I have the same masses but different materials, like let's say two pieces of clay, if you shoot them, if you have impact between two pieces of clay, we are going to have totally different velocities at the end. So the velocities at the end depends to the material property too. To include the material property, we can do some experiments, and people have done that and came up with this equation. They found a coefficient, which I'm going to explain later. What is that coefficient? Is going to be dependent to the velocity before impact and after impact. And this coefficient, which is called coefficient of restitution, is equal to the relative velocity after impact divided by relative velocity before impact. So E is going to be equal to the relative velocity after impact is v2 prime minus v1 prime. And the relative velocity before impact is going to be v1 minus v2. And the coefficient of restitution depends to the material property of these two pieces. So if we have very elastic material, E is going to be close to 1. But if you have very plastic or deformable materials, then E is going to be close to 0. So E is something between 0 and 1 means perfect elastic material, and Z means very plastic material, which we are going to actually lose a lot of energy. When E is equal to 0, it means V2 prime is going to be equal to V1 prime. So it means these two pieces are going to stick together and move together. And we are going to lose a lot of energy in that case. But if E is equal to 1, it means V2 prime minus V1 prime is going to be equal to V1 minus V2. So the relative velocity is going to remain constant. And the meaning of that is both of these materials are going to be very elastic, and we are not going to lose any energy. Okay?